Okay, hi there. So you see we have this simple circuit where through the animation we try to understand what this circuit is about. So as you can see, we have got this 6 volt DC voltage source, and there is a resistance of 1 ohm here. There is a resistance of 2 ohms here, and this is how the circuit looks completed. And because the circuit is completed, or there is a closed loop, as you can see, the current starts flowing into the loop, as also shown by the animation. Now the question is, what is the value of that current? As I said, we have got 6 volt DC voltage source. There are two resistances connected in series, 1 ohm and 2 ohms. So total resistance in the circuit is 3 ohm, 1 plus 2, that is 3 ohm, and the current would be I equals to total voltage divided by total resistance. So total voltage is 6 volt and the total resistance of the circuit is 3 ohm. 6 divided by 3, the resultant value of the current is 2 ampere, and that is how you see that this current is shown 2 ampere as seen by this arrow, and as shown by the animation, this current starts flowing. This is the arrow. Here the value is 2 ampere. Now this current is coming right here. Again through this arrow, the same current of 2 ampere flows through this 2 ohm resistance, and you see that it finally completes the loop. So it emanates from the positive pin of the voltage source and it terminates to the negative pin of the voltage source. So we can say that the positive charges are flowing in the direction of the animated dots, and the electrons, in other words, are flowing in the reverse direction of these animated dots. The question is, if you want to know the voltage across these resistances, or in other words voltage drops across the resistance, we can calculate that. We know there is a 2 ampere current flowing through this 1 ohm resistance, so the resultant voltage drop across this resistance would be resistance multiplied by the current, that is 2 volts. So here you say 2 volts drop across this 1 ohm resistance. At this node the voltage is 6 volt as shown, because positive pin is connected right over here, and 6 minus 2 volts will be 4 volt at this node. That's why we have indicated there is this 4 volt. So obviously at this node right here, with respect to ground, which is at 0 volt, we see that there is a 4 volts drop across this resistance of 2 ohm. In other words, we also can say the 2 ohm resistance multiplied by the current flowing through it, which is 2 ampere, is 4 volts, which is exactly what we have shown here. And if you see, the total voltage into the circuit will be 4 volts across this 2 ohm resistance plus 2 volts across this 1 ohm resistance. So 4 volts plus 2 volts is equal to 6 volts. So this is how you can see that we have calculated the voltages and the currents into the circuit and across the resistances. You can also apply the Kirchoff's voltage law, which states that the sum of all voltages in a closed loop is equal to 0. So you start with 6 volt minus The voltage drop across 1 ohm resistance is 2 volt minus voltage drop across this 2 ohm resistance is 4 is equal to 0.